Hey guys, and welcome to another episode. Today we are covering lesson 6.4 in our Florida's Best Mathematics book. Now, if you can see, I have my little Mathigon board here, so that way it's easier for you guys to visually see how we are going to compare fractions. I'm going to show you how to compare fraction with fraction tiles, but I'm also going to show you another strategy using multiplication to be able to determine which fraction is greatest, and of course which fraction is least. Now, when we are comparing fractions, this is our lesson 6.4, we always look at either the benchmark of 1/2 and we start from there, or just like I said, we compare the fraction to a fourth or to a half or to 3/4 or to a whole relative in size. I can use a benchmark to compare two fractions. That's actually one of our success criteria for today. So let's take a look at the first explore. Okay, I'm going to show you two different ways. First way is I'm going to show you how to compare the fraction 1/2 to the fraction 5/8. So one simple strategy that we can use is to write down our fractions 1/2 and write down our fraction 5/8, and you kind of you cross multiply. So what you do is you multiply this denominator 8 by the numerator 1. 8 times 1 gives me 8. Let's circle that number. And then you have the other side. We're going to multiply the denominator 2 times the numerator 5. 2 times 5 is 10. Now, all I have to now is use my number sense to compare which number is greater, 8 or 10. We know that 8 is less than 10, so therefore we know that 10 is the greatest, so therefore 5/8 is the greatest fraction. Now, that's one way to compare our fractions. So in other words, if I were to compare the fraction 1/2 to the fraction 5/8, I can say that 5/8 is greater using the multiplication strategy. Now, I want you to look over here. Here we have our fraction tiles. So I'm going to grab 1/2. Okay, here we go. There we go. Here's my 1/2. Now I'm going to go ahead and grab my 8ths. This is my 8ths. And I'm going to get only 5 out of the 8. So I have 5. And then I'm going to line them up. Okay. So if you can see which fraction is greater, 1/2 or 5/8, we know that 5/8 is greater. Now there's another way to tell as well which fraction is going to be greater. Let's go back to our half. How many eighths are equivalent to a half? Remember that lesson? If I wanted to find out how many eighths equal a half, I have to think 2 times what number gave me 8. 2 times 4 gave me 8. So 1 times 4 as well. That means if you look at the image, right, 4/8 is more than a half. 4/8 is a half. It's equivalent to a half. But in this case, we have 5/8. This is 4/8. That means 5/8 is more. If I'm comparing it to the benchmark 1/2, I have an extra eighth here. So that means that 5/8 would be more if you remembered your equivalent fractions. Okay? So that's another way to determine which one is greater. Now, let's go ahead. Let me erase all of this and let's move on to our second one. Okay. Well, here's the thing. This one is asking me 1/2 or 2/5. Again, I could use the cross multiply. 5 times 1 is 5. 2 times 2 is 4. That means that 1/2 is greater. But we're going to go ahead and use our diagram to see that as well. And here we have, let me highlight this again. These are our eighths. These are our eighths. So I'm going to get rid of these. And let's find our fifths. This is what I need. All right. So I have my fifths. All right. And it's 2/5. So let me line these up. And which one is greater? Correct. 1/2 is greater than 2/5. Right. 1/2 is greater than 2/5. Because, any fraction in fifths, in other words, if I had 2/5, those are not equivalent to 1/2. If I had 3/5, those are not equivalent to 1/2. Now, if I lined up my fraction tiles with 1/2, comparing those to the 2/5, therefore I know that that is greater. Just like I said before, we are comparing our fractions to our benchmarks 1/2. A benchmark is a commonly used number that you can use to compare other numbers. So you can use the benchmarks of 1/4, you can use a benchmark of 1/2, and of 3/4, and 1 to help you compare fractions. So in this example, they're using fraction strips to compare 7/10 to 3/8. So compare each fraction to the benchmark. Here we have our fractions. So we have 1, 2, 3, 4, 5, 6, 7 tenths. And we're comparing it to the halves. So if I were to compare 7/10 to 1/2, which one would be greater? Right, it would be 7/10. If I were to look over here, 7/10 ends at this point and 1/2 is here. Another easy way of telling, there's a lot of different ways, but if I wanted to see what was equivalent to 1/2 using tenths, think about it. What's half of 10? Half of 10 is 5. Or you can just do it what we did on the last lesson, which is to figure out 2 times what number gives me 10. In that case, we know that that's going to be 5 here. And if I multiply the bottom by 5, I multiply the top by 5. So this is going to be 5/10. That means if I know that 5/10 is already a half, and they're telling me that this is 7/10, well, 5 is less than 7, and 7 is greater than 5. So therefore, it would make perfect sense to say that 7/10 is going to be greater than 1/2. Again, I could use cross multiplication, and I could say 2 times 7 is 14, and 10 times 1 is 10, and right here I have 14. I already know that this was going to be my greatest fraction if you use that strategy. Now, if I were to compare 3/8 to 1/2, remember those equivalent fractions? If I had a half, how many eighths are equal to 1/2? I know that 2 times 4 is 8, so I have to multiply 1 times 4, and that's going to give me 4. That means that 4 would be equivalent, 4/8 would be equivalent to 1/2. But look at this fraction. This is a 3. What does that tell you? Right, if I were to look at the picture down here, I have 3/8 ends at this point. 1/2 is 1 more eighth that I'm missing. So I definitely have to say that 1/2 is greater than 3/8. 3/8 is less than 1/2. Remember, the mouth is open to the bigger number. Okay, so now let's go to the original question. They want us to compare 7/10 to 3/8. Again, we can use the cross multiplication strategy. We know that 8 times 7 is 56. And we know that 10 times 3 is 30. So we could always say, well, I know that 7/10 is going to be greater. That's one way. Or we can use our fraction tiles. If I look at 7/10 and then I look at my 3/8, which one is going to be greater? Correct. My 7/10 far supersedes my 3/8. So 7/10 is greater than 3/8. In other words, if 7/10 if 7/10 is greater than a half and 3/8 is less than a half, then it only makes sense to say that 7/10 is going to be greater than 3/8, because again, we're comparing it to the benchmark of a half. Here we go. Let's take a look at the next example. And here we have our number line. Use a number line to compare 5/6 and 4/3. So let's take a look at this one right here. Well, I have 5/6 compared to a whole. Well, a whole could be 5/5, 6/6, 7/7. Okay. But we're going to compare it to our, looking at our number line. It says use a number line to compare 5/6 and 4/3. Compare each fraction to the benchmark 1 whole. Okay. So we are comparing it to the benchmark 1 whole. Not 1/2, 1 whole. All right. I want you to think like this. If I had 6 as a denominator, what would be a whole? It would be 6/6. 6/6. This is a 5. Which number is less? The 5 is less. So that means it's not a whole yet. Because 5/6 is over here. I need one more sixth to make it 1 whole. So a whole, 1, is greater. Okay? If I were to compare 4/3, look at the 4. Which number? It looks a little different, right? Exactly. Because this is an improper fraction, boys and girls. If you have an improper fraction, in other words, the numerator is greater than the denominator, guess what that means? That means, look at the denominator. What would be a whole of thirds? It would be 3/3 would be a whole. This is a 4/3. This is a whole. That means if I have 4/3, I passed a whole. I'm not 2 wholes yet, but I'm over a whole. That means that I can easily say that 4/3 is equal to, it's not equal to, is greater than 1. So I can say that 4/3 is greater than 1 whole. Okay, because again, we're comparing it to the whole. So let's go back. Going back to 5/6 and 4/3. If 5/6 is less than a whole and 4/3 is more than a whole, then I have to compare these two fractions. Which fraction would be greatest? It would be the 4/3, because again, I have more than a whole. This fraction actually equals 1 whole and 1/3 left. So let's look over here, okay? Because I want you guys to understand. If I had 5/6, let me bring this back up. Let's look at our sixths. I had 5. Oh, I need one more. 5. Okay, there we go. I have 1, 2, 3, 4, 5, 6. 5/6. But I am comparing it to thirds. These are my thirds. I have 1/3. These are, well, let me make this a little bit bigger so you can really see my screen better. Let's compare that. I'm comparing it to 4. Remember, 1 whole, this is a whole. 3/3 is a whole. I'm going to show you why it's a whole. Here's my whole. Okay. All right. Here is my whole. All right. So this is a whole. What equals a whole? 3/3 equal a whole. But I don't have 3/3. I have 4/3. You see? 4/3 is 1/3 more than a whole. So when I'm comparing these two fractions, 5/6, when comparing them to the 4/3, is less. Okay? So 5/6 is less than 4/3. I just wanted you guys to see that so you see what I'm referring to. Now let me go ahead and keep my screen here. And let me clear my board. All right. Let's look over here. Use a model to compare. All right. Let's look at number 1. We're going to use a model. So we're going to use our board for this one. I need 12ths, right? Okay, so I'm going to use 12ths. Let's look at my 12ths. Here's my 12ths. And I need 5 of them. So let me count 1, 2, 3, 4, 5. Here we go. 5 12ths. Now I'm going to compare that to 3/5. So let me look at my fifths. There we go. Right, 3/5. So let me bring that down. 3/5. Okay. Let's line these up. Which fraction is greater? 3/5 would definitely be greater than 5/12. Now, I do have to say, there's a lot of different strategies out there for this, right? There's a lot of things that I've said. I'm going to go ahead and repeat those. I can use my fraction tiles, but if you're taking a test or something and you don't have access to fraction tiles, you need to know how to do the math, right? So you can use cross multiplication. That's one other way that I explained. So I could say 5 times 5 is 25. 12 times 3 is 36. So the mouth should open up to the 3/5. See? The other way I can do it is look at the denominators, 12 and 5. Okay, this is something you're going to have to remember. The bigger the denominator, the smaller the parts. So actually, if the denominator is bigger, in other words, greater, if 12 is greater than 5, right? Okay. If the denominator is greater, that means that my pieces are smaller, my parts are smaller, because I'm sharing it with more people. See, look over here. The smaller denominator has greater parts. The greater denominator, exactly, has less parts. So that's another way to remember, well, how do I know which fraction is greater and which fraction is less than? Because again, if you look at your denominators, you can use that strategy to say, well, let me see, the bigger the denominator, the smaller the fraction. All right, so here we go and look at, just like we did question 1, let's take a look at question 2. Here we are comparing 1/6 to 3/8. We can use our cross multiplication, or we can draw a model. I'm going to show you how to go ahead and draw a model, okay? So that way you know how to do it when and if you need to. Let's say let's do the cross multiplication first. So we have 8 times 1 is 8, and 16 times 3 is 48, right? Okay, that means 3/8 is going to be greater than 1/16. Let's say, however, I needed to draw it out. All right, I'm going to draw one rectangle. I'm going to divide that into eighths. So let me break that down into eighths. So that's 2. So remember, if I wanted to, I can compare it to a half because I have a half right here. But I'm going to go ahead and, break it into eighths. So here I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then I'm going to draw another rectangle attached right to it. I'm not drawing it separate. And since I know that 16 is double of 8, I'm going to copy my 8. Just like so. So now I have 8, but I'm going to double it because I need 16. Look at my parts, how small they're getting, right? Because I split them. Every time I fraction, I'm dividing, right? Okay, let's make sure that we have 16 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, here we go. So I'm going to shade in 3/8. Here's my 3/8. I know you can tell just by looking at it already exactly what you thought. I'm going to shade in 1/16. There you go. Which fraction is greater? 3/8 is greater. You see? 3/8 is greater than 1/16. And if I wanted to compare that to a half, think about it like this. Here it is. And I'm going to go ahead and write here, right? This is half. So if I really wanted to go a step further, I can compare them to a half. And then I can think, well, if this is a half, let's see. 3/8 is a little bit more, I just need one more eighth to equal a half, right? And if I have 16, I would actually need 8/16 to equal a half. So I already know that the 16ths are 1/16 is going to be less because 3/8 is the closest one possible to my benchmark of 1/2. That's another way of looking at it. Okay, and let's get going. Here we go. Okay, let's take a look at number 3. All right. So for number 3, we are going to look at 6/5 and 9/10. Again, this numerator is greater than the denominator, isn't it? So we could use cross multiply. 10 times 6 is 60. 5 times 9 is 45. Bingo. That's going to be the greater fraction. But I want you guys to really think though. This is an improper fraction. If I have fifths, how many fifths equal a whole? 5/5 equal a whole. This is one more fifth. So what does that tell you? It tells you that it's more than a whole. If I had a whole here, it would be what? 10/10. That's 9/10. So that's less than a whole. So I know that my greatest fraction is going to be my improper fraction, 6/5. That's one way. We did the cross multiply. That's another way. We could look at the denominators. Which is the smallest denominator? 5 is the least, right? But remember, the smaller the denominator, the greater the fraction. The bigger the denominator, the smaller the fraction it will be. So we use all of those different ways to determine which fraction was less and which fraction was not. The other way, all right, is using our fraction tiles. If I had fifths, let's look at my fifths. Here are my fifths. All right. Let me go ahead and minimize that so you could see it better. Okay, so I have 5/5. Right. I have 1, 2, 3, 4, 5. 5/5. What does that look like? It's equal to a whole. Correct. 5/5 is a whole. So 6/5 is greater than a whole. Now we're going to look at 9/10. Let's look at our tenths. Let me minimize it to the same number as the other two. Okay. I needed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I needed what? 9. That took one away. There you have it. Which fraction is greater? 6/5 is greater than 9/10. So therefore, that's why we put our symbol greater than. 6/5 is greater than 9/10. Got it? All right. Let's go to our next question. All right. So we can use cross multiplication. We can use fraction tiles. We can use a lot of different strategies to help us determine if the fraction is greater than or less than, or if it's equal to, or okay. So let's look at number 4. Again, we can use cross multiplication. 10 times 4 is 40, and 12 times 7 is 84. 7/10 is going to be greater than 4/12. Okay? Same thing. I can use my pictures to determine, or I can just look at my denominator. Less is more, more is less. So the bigger the denominator, the greater the denominator, it's actually going to be your smallest fraction. The smaller or the less denominator will be your biggest fraction. Which denominator is less? Less is more. Just remember that less is more. Look at number 5. I know we said less is more, but I want you to look real close if you notice something. Right. We're comparing it to a half, right? Well, the thing is that this is a half. Look at 3/6. Isn't 3/2 of 6? It is 3/2 of 6. How many sixths are equal to a half? That means I can tell already that I know that what? Like, how do I write? It will be 2 times 3. I would have to multiply the bottom by 3 and the top by 3. And I get that exactly. This is equal. I'm going to get the same thing. In this case, you have to also look really closely at the fraction that you're looking at, because it's equal. Now, if you would have used the cross multiplication strategy, you would have seen 6 times 1 is 6, 2 times 3 is 6. It's equal. Right. So here we have 2/10 and 5/6. Okay. We can use cross multiplication again. 6 times 2 is 12. 10 times 5 is 50. That means that 5/6 is going to be greater than 2/10. If we wanted to compare those two, then we would, let's go ahead and get all of these. All right, let's compare. We're comparing 2/10. So let me grab my tenths because I'm going to need those. And let me move it around. I need 2/10. Okay, 2/10. Let's grab our sixths. Here's my sixth. All right, and I need 5 of them. So 1 less. All right, here's my 5/6. And here's my 2/10. Which fraction is greater? 5/6 is greater than 2/10. That's using our fraction tiles. Okay? And you can also draw it out. So let me make some more space here. I just want you to see, I want to show you guys different ways that you can get the answer. All right, so now I'm going to go ahead and divide this into tenths. So I'm going to draw my rectangle here. And I'm going to divide it into 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to divide the other one attached right to it. And I'm going to divide that into 6. So let me start off with half. And let me do 3 over here. Okay. If I went ahead and I colored it and I shaded this in, I'm going to shade in 2/10. There we go. And then I'm going to shade in 1, 2, 3, 4, 5. I'm going to shade in 5 out of 6. 5, 6. Which fraction is greater? 5, 6 is greater than 2/10. Okay. So now we're getting somewhere. All right. Let's take a look at number 10. Okay. Same thing. We can use cross multiplication and say that 8 times 5 is 40 and 4 times 3 is 12. That's going to be greater. We can also draw an image, or we could just look at the fraction. If I look at the fraction, this is 5/4. I know that 1 whole is 4/4. This is plus 1 more fourth, which gives me 5/4. So what does that tell you? It's more than a whole. It's greater than a whole. So that's why it is greater. That's why it's greater. Now, all right, so let's take a look at number 11. I wanted to compare, now I'm going to compare the fraction 6/12 to 4/5. If I were to compare to a half, and I wanted to see how many 12s were equivalent, I know that 2 times 6 is 12. So 1 times 6 is 6. 1/2 is equivalent to 6/12. So this is actually 1/2. But look at this fraction. I'm going to compare this to a whole in fifths. How many fifths would equal a whole? 5/5 equals 1 whole. I know 1 is greater than a half. That we do know, right? So based on that, I'm going to show you 2 with images so that you could see. Here's my whole. Here's my whole part. Here's my whole part. Okay? I put that at 6. Okay. So here's my whole part. And now I'm going to compare half. Let's do that too. Bring this down to 6. Okay. I'm going to go ahead and compare a half. Here's my half, which is half of a whole. Okay. And I'm going to bring in my 12ths. Also, I'm going to go ahead and bring in my 12ths. And I know that I needed, let's see, 1, 2, 3, 4, 5, and 6. 6/12 is equal to a half. Okay? 6/12 is equal to a half. 1/2 is less than a whole. Now let's bring in our fifths. Here's my fifth. And I need, it says it right here, okay, I need 4/5. 4/5. Well, I know that if I were to compare 4/5 to a whole, 5/5 is a whole. I only have 4/5, but I'm so close to a whole, I just need 1 more fifth. If I were to compare the 2 fractions as 12ths or fifths, I would definitely understand and see for myself that 1 and 4/5 is greater. Now, I can also look at the denominator, which is the least denominator. 5 is less, right? Remember, less is more. So the smaller the denominator, the greater the fraction. So for number 11, we can say that 1 4/5 is the greater fraction. Okay? All right. Let's take a look at number 13. Let's do a word problem. A black bear hibernates for 7/12 of a year. A bat hibernates for 1/4 of a year. Which animal hibernates longer? Well, let's compare. First of all, let's highlight what we need to know. What they're asking me is, I need to find out the greater fraction. Okay? And I'm going to put my fractions here. 7/12 is what? To 1/4. So I have 1/4 here and I have 7/12 here. Okay. I could do two of two things. I can draw it out, or I can compare. So if I use cross multiplication, I know that 4 times 7 is 28, and 12 times 1 is 12. Therefore, I know that should be my answer, right? Okay, but I want to prove it. Okay, let's go to our math board. I'm going to go ahead and take 12s. I'm going to take 7 of them. And let me minimize this so you guys can see it. Okay. That's 12. That's 11, 10, 9, 8, 7. Here we go. Okay, so we have 7/12. Now let's use our fourths. Let's grab our fourths. And let's see. I made this one 7. Okay, so let's shrink this down. Okay. And I only need 1/4. So let me break all this down and let me put them together. Which fraction is greater? 7/12 is greater than 1/4. 7/12 is greater than a fourth. Now, yes, we have said that the greater the denominator, the less the fraction, or the smaller the fraction is. Yes, it is smaller the part, but we are only comparing it to 1/4. And I know if I were to compare 12s to fourths, let's put it this way. If I needed to find out how many 12ths are equivalent to a fourth, 1/4 equals how many 12ths? Well, let's think. If I had a 12 here, I would need to multiply 4 times 3 and 1 times 3. That means for it to be 1/4, I only need 3/12. So this is 7/12. That's more. That's why 7/12 is greater. And that's why in this case, since we're only comparing it to 1/4, right? Not more than a comparable fraction, not more than that benchmark that we're looking at, we would have to really look at the fraction itself to determine which one is greater or not. We can use a lot of strategies. Again, like I said, we can do cross multiplication, right? 4 times 7 is 28. 12 times 1 is 12. The 28 is greater, so 7/12 is greater. That's going to work. If I were to compare, in this case, I would not compare in other words, in this case, I would not compare the denominators. I would actually do what I did here. I would say, well, if I'm only comparing it to the benchmark of 1/4, remember there's different benchmarks for this lesson. This is the benchmark of a fourth. I would then say, well then, if they're giving me 12s, how many 12s are equal to a fourth? 3 12s are equal to a fourth, and this is 7 12s. 7 is greater than 3, so I have more than a fourth, right? And I could also, again, use fraction tiles or draw it out. If I draw it out, and I will show you what I mean. So let's say I draw this out. All right, I'm going to do here 6, because I always start with my baseline. What's half of 12? 6 is half of 12. And then I'm going to divide that into it again. Now, I'm going to count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to compare it to fourths. 1, 2, 3, 4. I just want you to see You have to check your work all the time. If I look at 7/12, let's color in 7. 1, 2, 3, 4, 5, 6, 7. Let's color in 1/4. Right. So I far superseded it. As a matter of fact, what I was telling you before, if I draw a line right here, how many thirds are equal to a fourth? 3. Well, not how many thirds, how many twelfths, I'm sorry. How many twelfths are equal to a fourth? 3/12, you see, are equal to a fourth. So right there, you even see the equivalent fraction of it. And it already passed it. So I just wanted you guys to see that's why it's greater.
Dance, it's called the Cupid Shuffle. It don't matter if you're young or you're old. Here we go. We gon' show you how it goes. To the right, to the right, to the right, to the right, to the left, to the left, to the left, to the left. Now kick, now kick, now kick, now kick. Now walk it by yourself. Now walk it by yourself. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. Down, down, do your dance, do your dance, do your dance. To the right, to the right, to the right.
So let's take a look at model real life. Okay, in this example, let's go ahead and read the prompt. It says you have 3/5 of a bottle of blue paint and 7/8 of a bottle of yellow paint. Do you have enough of each paint color to make the recipe, and explain? Compare each fraction of a paint bottle to the benchmark 1/2. Okay, so let's take our little benchmark 1/2. Here it is. 1/2, and I am going to compare 3/5 to that. Let me bring that back. All right, so I have 3/5. Let me move that over. There we go. Okay, so if I were to compare 3/5 to 1/2, I say that 3/5 is greater than 1/2. I could use cross multiplication too and say 2 times 3 is 6 and 5 times 1 is 5. So therefore, 3/5 is greater. Let's take a look at the next one. I'm comparing eighths. Now, I also want you to remember, I could use a picture, of which we are, but let's see. How many eighths are equal to 1/2? 2 times 4 is 8, so 1 times 4. So that means in order to have a half, I need 4/8. I only have 2. So that should tell me that 1/2 is greater, right? I could use cross multiplication. 2 times 2 is 4. 8 times 1 is 8. Okay. So again, 1/2 is greater. Let's look at a picture. I'm going to compare 2 eighths. So let's grab our eighths. And I'm only going to need 2. Okay. 2 eighths, according to what I did, is going to be less than 1/2. In other words, 1/2 is greater than 2 eighths. Is it? Look at my half and look at my 2 eighths. Let's move that to the side. 1/2 is greater because I actually need 4 eighths to equal 1/2, but I only have 2 eighths that equal 1/2. So we were correct. So that means, so far, we are understanding it, right? The last one says 3/5. Now I have to go back to the original one. Do I have enough? If I have 3/5, what am I comparing? It says, again, I have 3/5 of a bottle of paint. So what can I say about 3/5? 3/5 compared to 2/8 tells me that, which is greater? It tells me exactly. It tells me that 3/5 is greater. Let's compare the yellow paint. That was just the blue paint. Because again, I had 3/5 of a bottle of blue paint. Now we're going to compare the yellow. So remember our equivalent fraction? I had 4/8 that equals a half. This is 7/8. So 7 is more than 4. I have more than a half already here. I could also again cross multiply. 2 times 7 is 14. 8 times 1 is 8. 14 is greater than 8. Or I could say, okay, well, if I am comparing it to a half, I had 4 is equal 5, 6. It's already off my page. 6. So you see what I'm saying? 4 is equal 5, 6. Exactly. 7 is going to be more. 7/8 is going to be more than a half. If I look at 5, now again, if I look at 5/10 compared to a half, I know that 5/10 is equal to a half because again, what's half of 10? Half of 10 is 5. Okay? So I know that these two are equal. 2 times 5 is 10. 10 times 10 is 10. They are equal. So now let's compare the yellow paints. If I were to compare 7/8 to 5/10, 5/10 is a half. Remember, 5/10 is equal to a half. So this is really 1/2. That tells me that 7/8 is greater. 7/8 is more, because remember when we were looking at our eighths, I can keep going up to 7. It's already past a half. Once it passes 4, it's greater than a half. So I do have enough paint color to use. I do have enough of each paint color to be able to make the recipe. I do. Okay guys, so I hope you enjoyed this video for today. Remember that when we're comparing fractions, there's a lot of different strategies that you can use. If you want to practice at home, I was able to find this amazing app. It's called Mathigon. You could see it right here on the screen. It's absolutely free. I think it's amazing. It has a lot of different things that you can do. For example, you can look at your fractions. If you don't want to use fraction bars, you can use fraction circles. It's called Mathigon Ploypad, and it's a virtual manipulative. So it's really cool, and you guys should check it out. So I hope that you enjoyed my video, and stay tuned. Make sure that you subscribe to all of my, to my channel so that you can stay up to date with all of my videos. All right, guys, bye.